Alright, now to page 2 for our review. Another graph to look at, y equals 2 to the x minus 2. So from here, I want to find all these good characteristics again. Domain, range, asymptote, zeros, etc. So my domain, remember with exponentials, always going to be negative infinity to positive infinity. Okay, always, 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 because this graph is going to exist for all x values. My range, I read from bottom to top. Oh, here's where it starts. And it goes up and up and up and up and up. So it's going to start at y value negative 2. Go up forever and ever and ever until we hit infinity. Remember, negative 2 has to have parentheses. Okay. My asymptote is going to be at y equals negative 2. There's the dashed line that I see here. It's never going to cross. Remember, that kind of matches up with my equation as well. Kind of, it does. And that's important there, because that's what tells us the asymptote. 0 is where it crosses the x-axis, right here. 1, 0. And with parabolas, remember, we typically either saw 2 x-intercepts or zeros, or none. There's a rare case where we only saw 1. Here, we're almost always going to see 1 or 0. Okay, you're never going to see 2 x-intercepts here. And number 5, remember we specify this as my y-intercept, where it crosses the y-axis. Okay, it's going to be at 0, negative 1. We can tell that by the graph, but we can also plug in to find it. So, I'll backtrack for a second. We're going to get rid of number 9. We haven't touched that yet. We are going to save it for a little bit later. So remember, to algebraically find the y-intercept, we need to plug in 0 for x. Remember, the y-intercept is going to be when x is 0, whereas it crosses the y-axis. So, 0, plug in 0 for x. So when we do that, we get y equals 2 to the 0 minus 2. Remember, anything to the 0 power becomes 1. So we have 1 minus 2, which is negative 1. And remember, that's just to remind us when it's not perfectly on a point like this one is, how we can find it. Okay? Interval of increase, interval of decrease, remember, one or the other, not both. This one, as we read from left to right, it's going up, right? It's increasing. So we have an interval of increase. That interval is going to be from, you guessed it, negative infinity to positive infinity. Remember, our intervals are always going to be that, because it's always doing the same thing. It's either always increasing or always decreasing. Okay? Even when it flattens out and it looks like it's only increasing by a little bit, it's still increasing. Interval of decrease, none. Remember, we can only have one or the other. Okay. And this one, you have to spell out the end behavior. So remember, we have two scenarios. We have when we go to the left, we have when we go to the right. So, as x approaches negative infinity, it's going to be to my left. As my graph goes to the left, my y approaches that asymptote, right? It gets closer and closer and closer, so my y approaches negative 2. Okay? And my other one, as x approaches infinity, goes to the right, y also goes to infinity. It goes up and up and up and approaches positive infinity as well. This one is to my right. The L and R are not needed. It's just my way of reminding us what we're doing. So my answers there should be as x approaches negative infinity, y approaches negative 2. And I'm going to get rid of that L and R. It's kind of confusing. Nope, I did not want a highlighter there. Let's erase that. Pen, we're taking out number 9. Put my my answer here in yellow highlighter. There we go. So that's my end behavior answer. Okay. From here, if everyone's good, again, pause as needed. If we go down, okay. So now we have equations, and it's asking us for the different scenarios, right? Which one encompasses which thing, okay? Test taking strategies here, right? So think about each one, process of elimination through, even though you can use the equations more than once, but we want to approach it as though, kind of deciding which ones do this not apply to, okay? So which equations have an asymptote of y equals -1? So remember, when we have our equation, we have talked about so far, we haven't gotten deep into transformations yet, but we have talked about y equals a b to the x, right? A is my initial, sorry, this pen is not working very well, amount, okay. B, growth, decay, factor, okay, remember, growth was when b essentially is greater than 1, and decay is when b is bigger than 0, but also less than 1. So essentially it's a fraction, not bigger than 1, okay? But then we also said, we touched on this, we haven't talked about transformations, but we touched on the fact that whatever number was out here could be minus also. This was what corresponded with my asymptote. Okay, asymptote. Well, we've really focused so far on finding that graphically. So here, okay, which ones have an asymptote of -1? Oh, not A. Okay, so we'll do number 10 in green. Okay, not A. That's a positive one asymptote. B would, because this outside number is -1. C would, the outside number is -1. D would not, so there's no outside number. Remember, if we're talking about D, that's like saying plus 0. The asymptote is at 0. Okay, so not A, not D, so we're looking at B and C. Okay, we'll do the next one in red, number 11. Which equations have a domain of all real numbers? All exponential equations have domains of all real numbers. A, B, C, and D. All of them do. Okay? Now, which ones are decay? Remember, that's the one where my B value. We'll do this one in blue. Okay? Decay. My B value is less than 1. Okay? But greater than 0, obviously, so it's a fraction less than 1. So number 2, or I'm sorry, in letter A, my B value is 2. B is the number that's directly associated with the exponent. Okay, so it's not A. B, I have y equals 2 parentheses 1/3 to the x. The 1/3, less than 1, is the one associated with the exponent, therefore that is exponential decay. So we have B. Okay. C. Nope, my B value is 2 again, so it can't be C. And D, this one trips us up a lot. We have 3/2, so we see a fraction, so we immediately think yes. Okay, but remember, we can have improper fractions too. 3/2 is really 1.5, which is bigger than 1, right? Or 1 1/2. So you gotta be careful careful. You can't constantly trigger fractions with decay. You gotta make sure that it's not a mixed number fraction bigger than 1. So this one we only have B as our answer. And that is your Unit 4 quiz review. Answers for you. So for today, again, I would do this review. Use this, pause as needed, make sure you understand it. Then the short quizzes assignment. Tomorrow I will assign another quizzes that will be your quiz for the exponential unit. And shoot me an email if you ever have any questions. Bear with me. Be flexible, be patient. Put in that little bit of effort and we will be good and back to school in no time. Stay healthy.